Hello, this is Rahul from Medplum, and in this video I'll be showing you how to set up a complete instance of Medplum on AWS from the ground up. In this example, I'll be setting it up in the EU West 2 region to demonstrate some of the steps required for self-hosting outside of the US. We'll be following the directions in our public documentation, which you can find by clicking on Documentation, Self-Hosting, Install on AWS. So our first step will be to install the AWS CLI tools into our system, which will give us access to AWS utilities. So I'll scroll down here to the AWS CLI setup and click this link to go to the AWS CLI documentation. Because I'm on Mac OS, I'll click the installer on the right for Mac OS, download it, and install the AWS CLI tools. After we've installed the tools, we can open up a terminal and type in the command AWS to see if we get a successful response, as I've shown right here. Our next step will be to set up our AWS credentials so that we can use the CLI tools to modify our cluster. So I'll click on the instructions, and then on the right, I'll select Set and View Configuration Settings using commands. That'll be the technique I use. And the first step I'll do is to go to my AWS console, look at the IAM dashboard, click on My Security Credentials, scroll down to the Access Keys section, click on Create Access Key, select the CLI section, give our access key a name or a description here, and then I can open up a terminal, run the AWS configure command, and copy in my access key, my secret, add the default region, which in this case is going to be EU West 2, and then how I prefer the output, which will be JSON. After that, I can use the AWS IAM get user command to confirm that my credentials have been set up properly. Future steps will ask for your AWS account number and will have required that you set up your AWS permissions. For now, we're going to skip those steps in this video, and we're going to move on to configuring your DNS name servers. We recommend that you use AWS to manage your DNS, as it allows the Medplum deployment tools to set up the required SSL certificates for running Medplum. In this example, we'll show you how to use Route 53 to set up your DNS. If you choose not to use Route 53, you'll be responsible for all your own DNS and SSL certificate setup. So we'll open up the AWS console again and select the Route 53 service. Our next step will be to create a new hosted zone. We will specify the domain that we've registered. In this case, we'll be hosting at foomedical.dev. Then click Create New Hosted Zone. And you can see here the new foomedical.dev hosted zone has been created. Next, we're going to tell our domain registrar to use the custom name servers set up by Route 53 instead of its default name servers. In this example, we use Namecheap to register foomedical.dev. So we'll pull up our Namecheap account, select Custom DNS, and then copy the name server addresses from Route 53 to your registrar. Now your registrar knows to use your Route 53 name servers to handle your domain's DNS. For those of you who want your Medplum cluster to send system emails, we highly recommend that you set up Amazon's simple email service. However, this is out of scope for this video. The next step will be to choose an environment name for your Medplum cluster. This environment name will be used to namespace all the relevant AWS resources and configuration settings inside your AWS account. We recommend creating at least a staging as well as a production environment. Next, we'll create a new NPM package for our infrastructure as code tooling. This repository will contain all of our dependencies and configuration files for the Medplum CDK. So we'll open up our terminal and we'll make a new folder called Medplum AWS Tutorial. Then we'll cd into that folder and run npm init. Next, we'll install our CDK dependencies. Then we'll install two Medplum dependencies, Medplum CDK and Medplum CLI. Our next step is to create a new file called cdk.json. This will be a simple JSON file with the contents copied from the instructions. This is a configuration file which tells the AWS CDK tooling to use the infrastructure as code described in the Medplum CDK package. We'll copy the contents from the instructions on the right, then save. And here I'll just confirm that the file has been written properly. Good! Our next step will be to run the AWS init tool. This tool will walk you through a series of prompts that will help you write your Medplum server configuration file. It will also generate any necessary signing keys needed for the Medplum binary storage. If you configured your DNS via Route 53 as shown earlier, it will also set up the appropriate SSL certificates. Lastly, it will save your configuration settings to the AWS parameter store. So we'll run the npm medplum AWS init command from Medplum CLI. This will bring up an interactive set of prompts to configure your environment. First, we'll select an environment name, and in this case, we'll use tutorial. We'll use the default file name in this example. Next, we'll select the region for our Medplum instance. As I mentioned earlier, we'll be creating this Medplum cluster in EU West 2. The prompt will then confirm your AWS account number and propose a default name for your cluster. Here, we will stick with the default name. Next, we'll enter the domain name we configured in Route 53, fumedical.dev, as our base domain name. We'll add a support email address, which will be used for system-generated emails such as new user invites. In this case, we'll use support@fumedical.dev. Next, we'll be asked to confirm the domain names for our API, binary storage, and Medplum App endpoints. These are generated off of your base domain name. Typically, it makes sense to stick with the defaults. Next, we'll be asked to confirm the name of our S3 storage bucket. This is the bucket that Medplum uses for binary storage for things like images, PDFs, etc. Again, we will use the defaults. Next, we'll select how many availability zones we want to use for our Medplum cluster. Since this is just a tutorial cluster, we will stick with the minimum of 2. Next, we'll add the configuration for our database. We have two options. Either Medplum can set up an RDS database for us, or we can point Medplum to an existing RDS instance. Since we are starting from scratch here, we'll have the CDK spin up a new database for us. In production, you typically want 2 instances for high availability. Next, we'll set up our API servers. Medplum currently runs 3 parallel servers in our cloud product, but for this tutorial, we'll just spin up 2 instances. For each instance, we'll configure the amount of memory, 512 megabytes in this case, and the amount of CPU, 256 here. Next, we'll select which Docker image tag to use on our API server. By default, we deploy medplum:/latest. Now we'll set up SSL certificates for our 3 subdomains, API, storage, and app. Because we used Route 53 for our DNS, we can use the DNS option to automatically validate the certificate. Lastly, the init tool will summarize the configuration values used and prompt you to store them in the AWS parameter store, which is the cloud-based secret store that Medplum uses for all sensitive values. It's generally best practice to use the parameter store, so we'll select yes. And that's it. We've now successfully set up the configuration for our Medplum cluster. Now we'll use the AWS console to validate our configuration. First, we'll use the Systems Manager to make sure our configuration parameters were stored successfully. We click on Systems Manager, and on the left, click on Parameter Store. We can see here a number of secrets that are stored under the path Medplum, tutorial, which is our current environment, and then the name of the configuration key. For example, we'll click on the base URL to confirm that it was set to foomedical.dev. Next, we'll confirm the CloudFront distribution. We'll make sure that in our distribution, we have a valid public key that is used to assign pre-signed URLs for binary storage. Our next step will be to validate our SSL certificates. The instructions ask us to go to the Certificate Manager in the AWS console. We'll see that we have a pending validation for api.foomedical.dev. We also have two pending validations for app.foomedical.dev and storage.foomedical.dev. Because these two certificates are related to CloudFront and S3 respectively, they are in the global region, also known as US East 1. So to validate our first certificate, we'll click on the link, and then we'll select Create Records in Route 53. This is the benefit of having used Route 53 for original DNS. By clicking this button, it will automatically add the CNAME records to our DNS in Route 53. We'll click Create Records. There we have it. We've successfully created the DNS records for api.foomedical.dev. We'll do the same thing in the global region for app.foomedical.dev and storage.foomedical.dev. Now we can go to Route 53 to confirm that the CNAME records have been added to our hosted zone. So click on our hosted zone, go to foomedical.dev, and then we can see that we have 3 new CNAME records, one for api.foomedical.dev, one for app.foomedical.dev, and one for storage.foomedical.dev. Next, we'll run this CDK bootstrap. This will provision some initial resources that are necessary before you can deploy the Medplum cluster itself. So we'll run npx cdk bootstrap, and we'll point it to the configuration file that we set up for our cluster, that is medplum.tutorial.config.json. Next, we're going to run the cdk synth command. This is a useful command that CDK provides to find any logical errors in your configuration. So we'll run npx cdk synth and point it to our configuration file, which is medplum.tutorial.config.json. And we'll see here that we get the all clear. Everything looks good. The last thing we'll do before we deploy the CDK is to run the cdk diff command. This will give us a summary of all the changes that will be made before actually updating the resources in AWS. You can think of this almost as doing a little dry run before we provision the AWS resources. So we'll copy the cdk diff command from the docs on the right, npx cdk diff, and we'll point it to the same cdk configuration file that we have been previously. Then we'll hit enter. And what you can see here is a list of all the changes that the AWS CDK will make to our CloudFormation stack. So now we're ready to run the main command, npx cdk deploy. This will actually spin up all the necessary Medplum resources in our AWS cluster. So we'll copy the command npx cdk deploy and point it to our configuration file. Oops, and I got a little error here because I forgot to include the --all flag. So it'll be npx cdk deploy and point it to our config file and include the --all at the end. Now, this next step will take a while, somewhere between 30 minutes to up to 2 hours, depending on your configuration, because it takes a while for the CDK to actually spin up all the different resources, provision them, and make sure that they're working. In this video, we'll skip ahead to the end here, but just keep in mind that this can take a while. Because we are deploying in a region other than US East 1, we have one additional step here. We need to update the policies for our S3 buckets. So you can see that we give you the command here, npx medplum AWS update bucket policies, and we'll have to give it our environment name as well, which is tutorial. Before we do this for real, we'll run it with --dry run just to get a sense of what's going to happen. Here we can see the 2 bucket policies that will be updated. Okay, let's run this for real. Here you can see the confirmation that our bucket policies were set up correctly. Our next step will be to deploy the Medplum app. So we'll just run the npx AWS deploy app tutorial. And there you go. Now we've deployed the Medplum app. So now we'll test this out and see if the Medplum app is running. So I'll go to app.foomedical.dev. And success, we can see that the login page shows up. We'll sign in with the admin credentials, which is admin at medplum@example.com and medplum_admin. We can see that we get the Medplum admin console up and running. And if we click on the top right, we can see that we are logged in to the super admin project as Medplum admin. Now, please check out our documentation for the details on what super admin means. But in general, your first step here will be to create a new project that does not have super administrator privileges. This is where you can put your main clinical data. Best practices typically are to create at least 3 projects: a developer project, a staging project, and a production project. Next, we'll log into the AWS console and just do some validation checks to make sure our cluster was set up correctly. The first thing we'll look at is our CloudFormation stack. So if we click on CloudFormation, and then we can open this up and we'll see that we have a new stack called Medplum Tutorial. We'll use the right-hand bar to see all the resources that were set up under this stack. So if we click on the Resources tab, you can see all the resources under this stack. And we'll look at the back end. And the main one we'll see here is Fargate for the API service. Look at the front end, we'll see we have a bucket that will be where the content for our app.foomedical.dev is stored, the Medplum console app. If we look at storage, we'll see that we have a bucket created for the binary storage associated with this Medplum deployment. Next, we'll go to the AWS parameter store under Systems Manager. Here, what we want to see is that we have a number of configuration parameters set up, all under the namespace medplum/tutorial. And here we can see we have all of our configuration settings set up right here under My Parameters. Next, we'll go to S3. And here we're looking for 2 buckets. We have the bucket for our app, which is at app.foomedical.dev, and we have the bucket for our binary storage for this Medplum instance, which is at storage.foomedical.dev. Next, we'll check out Fargate, which is under ECS. This is where our API servers will be running. So we can see here we have ECS set up under the Medplum tutorial cluster, and we have 2 tasks actively running. Next, we'll check out our database, which is in the RDS service. So we'll click here, go to our database instances, and we can see that we have 2 instances of RDS right here, one reader and one writer instance, all under the Medplum tutorial cluster. Next, we'll go to CloudFront, which is the Amazon Content Delivery Network. And what we can see is we have 2 entries here under foomedical.dev, our current domain, app.foomedical.dev and storage.foomedical.dev. The other thing to note is that because CloudFront runs in the global region, the region selector at the top is switched to global. Lastly, we'll actually check that our API is up and running by going to api.foomedical.dev/healthcheck. Here we can see we get a positive response. OK is true. We have the current version deployed, and Postgres and Redis are confirmed to be up and running. Our next step will be to deploy the bot lambda layer. This is the package of dependencies that Medplum bots use when running on AWS Lambdas. This step requires cloning the Medplum source repo. So we'll run git clone. Once that's done, we'll step into the directory. And last step is that we'll run the deploy bot script. And that's it. Now we'll go to the AWS console to make sure it works. We'll first take a look at the layer ARN that was produced by the deploy script. Then we'll log into the AWS console, and we'll go to Lambdas, Layers, and we can see that the layer with this ARN has been produced. It has the name Medplum Bot Layer. Finally, we're going to validate that this all works by running a simple smoke test. In this test, we're going to create a patient, upload a binary file, and create a simple bot. So let's go ahead and log into app.foomedical.dev. And we'll log in as our admin user. And the first thing we'll do is check what project we're in. So if you remember earlier, I said by default we're in the super admin project. So we'll look at our project switcher on the top right. We'll see that we're in the super admin. First thing we'll want to do is create a new project. So we'll click Add Another Account and click this link at the bottom here to register a new project. We'll sign in with the same user, the admin user, but now we'll be prompted for our project name. So here we'll call this project the smoke test. Great, and now we have a new project. And here we'll make a new patient. So we'll make a patient called Homer Simpson, just as a test patient. Gender. We'll click OK. Great. Now we've confirmed that basic resource creation is working properly. So now we're going to test out binary storage by updating this patient with a photo. So we'll go to the Edit tab and scroll down and upload a photo. Here we go, and then we'll click OK. Given that we see the preview, we know that binary storage is also working correctly. Medplum stores all these binary blobs in the S3 storage bucket that we set up. The next thing we'll do is to create a simple bot to test out our system. To do that, we'll first have to enable bots on our smoke test project. Bots are a project level feature and need to be enabled by the super admin. So we'll switch into the super admin project. In the resource selector, we'll select the project resources. Then we'll see all the projects loaded into the system, and we'll click on our smoke test project. We'll go to Edit, and then we'll scroll down to Features, and we'll enable the Bots feature. Click OK, and now bots are enabled on our smoke test project. And we'll switch back to the smoke test project. Now that bots are enabled, we'll build our first bot. So we'll click here on Project, and Then we'll go to bots, create new bot. We'll call this our smoke test bot and click create bot. Now we'll go to the new bot and it will open up the editor tab. This is where we can write code and deploy this bot. In production use cases, you wouldn't use this editor tab. This is good for quick and dirty editing of bots. Check out our bots in production documentation for how you would do this in a real production setting. So here I'm going to just build a simple bot that greets the patient by their name. And just a note that the bot should always return a valid JSON object. Here you can see our message is returned successfully. And that's it. Now we have a fully working Medplum cluster. So let's recap what we did. We first set up our AWS CLI tools and credentials. Next, we set up our DNS in Route 53. Then we cloned the Medplum CDK tools and ran the init script to set up our initial configuration. Next, we ran the CDK deploy to spin up all the necessary AWS resources. And then finally, we deployed the Medplum app. At the end of it, we tested all the major components, which were basic resource creation, binary storage, and bots. Thank you for following along with this video. We hope that this is helpful for you as you set up your self-hosted instance of Medplum.